Alright, so let's start with this. Alright, hang up. Get focused. So we're going to start with a couple of equations here. Hey, there shouldn't be a whole lot of talking all between each of you. Okay, but here's the system of equations that I wanted to solve using substitution. Okay, so let's start out with the question of what does it mean to substitute?
Sub in.
Sub in. What happens when you sub in?
Somebody get out.
Somebody gets out. So if you are one of the tall, power forward, kind of center post people in a game, and you sub in, who are you normally going in for? The same position, for sure.
But not me though.
Okay. But you're subbing in, as you sub in for a guard, that means you're a guard going in for a guard. If you sub in for a post, you're now a post going in for a post. So you're subbing in something equal. It'd be great is when you sub in somebody in a basketball game or football game, you're subbing in somebody with exactly equal ability, so you're not losing anything when you sub in. That'd be great. That doesn't always happen. In math, though, when you sub something into another equation, it has to be equal. So you can't just say, oh, I'm going to put an x here because they said to sub in even though there's a y. No, we got to find out what y is equal to before we can replace y with that. And so when we do substitution, we got to find something equal. To do that, you're going to look at your equations. You got to figure out which equation is the easiest to solve for one of the variables. So what does that mean? It means which equation can I figure out how to get a variable by itself the easiest. So if I look at that second equation and I look at the y, there's no coefficient with the y. So in this kind of problem, that's the easiest variable to solve for. This variable right here is the easiest to solve for. And so what we're going to do is we're going to get y by itself in that second equation. So how do I get y by itself in this equation? What do I got to get rid of? Subtract 2x. Alright? So I need to get rid of that 2x. I want to subtract it from there and do the same thing on the other side. So that eliminates that 2x there, and I got y equals a negative 2x plus 10. Okay, so at this point, I know exactly what y equals. Y equals negative 2x plus 10. Yes? Yes, it can be 10 minus 2x. And that'll end up being the same exact thing. So it just depends on if you put the variable in the front or the back. Negative 2x plus 10 and 10 minus 2x are the same thing. Okay? Okay, so now we know what y equals. Y equals this. So we're going to go to the other equation and we're going to replace y. We're going to substitute in for y with what y is equal to. So I'm going to rewrite that first equation, 3x plus 4, but where y is, I'm going to put in parentheses negative 2x plus 10. And now I have equals 12. Okay. So I wrote that exact same equation, the first one, but I replaced y with what y is equal to. And the good thing now is I only have one variable. I have x to deal with. So now I can actually find what x is as a specific number, not just random variables like the y. We found what y was equal to, but it still had an x in it. I want an actual value. So now that we just have the one variable, I can do that. So first up here, just bring down the 3x, and then I need to distribute. 4 times negative 2x is a minus 8x, and then 4 times 10 is a positive 40. So that first step, all I did was distribute the 4 to the negative 2x and to the positive 10. Questions so far? Now, I know we just got started, y'all, but most of y'all are doing a really good job of paying attention at this point, so I appreciate it. All right, next step, combine your like terms. So what is 3x minus 8x? Negative 5x. Okay? So negative 5x plus 40 equals 12. And then there's two more steps I got to do here. I need to subtract the 40 from both sides and then divide both sides by negative 5. Okay? So I want the x by itself. So subtract 40. Negative 5x equals negative 28. And then divide by negative 5 and get x equals 5.6. Okay, so my x value for this problem, for the solution, is 5.6. Now this is a problem that's very specific of, there's a reason why we choose to do something other than graph. Because picking out 5.6 on a graph is not an easy thing to do. Okay, unless all of your lines are like 1/10. And then you can figure it out. But most of the time they're not. So it helps us to have another method other than just the graph. Alright, second thing on this, now that we have what x equals, we know x equals 5.6, we still need to find out what y equals. Okay, so we're going to take our value for x, which is 5.6, and we're going to substitute it into this equation where x is to get y. Oh, somebody's lost their agency points. I heard that it's too much phrase. Huh? No, we still got to find x, because the solution is an ordered pair. Y'all, just as a reminder, solution, if you have a system of equations, is an ordered pair. So you have to have an x and a y. Okay? And so now we got to get the y. So I'm just going to plug in negative 2 times 5.6 plus 10. So all I do is replace the x with what x is equal to. So that same process. Negative 2 times 5.6 is negative 11.2. So negative 11.2 plus 10 is negative 1.2. Okay. And so when I write my solution, it's an ordered pair, and it's x, which is negative 5.6, comma y, it's not negative, sorry, it's positive 5.6, comma y, which is negative 1.2. So that, so there's my solution. Okay. Questions on this problem? Okay. So a couple things. When you're trying to use substitution to solve a system, you have to get a variable by itself in one of your equations. That's the place where you got to start. Once you get a variable by itself, that's when you can start substituting back in. So in this problem, we got the y by itself first, and then took what y was equal to and plugged it back into the other equation. Okay? All right. So next one. Alright, so here's the next one. We're going to do the same process. Same process. We're going to solve this system of linear equations using substitution. Alright, so first question. Which equation and which variable is easiest to substitute in for? Second equation. Okay, why? Because there's only like x and y. In other words, there's variables there that do not have any coefficients other than 1. So that makes it easier to solve. So does it matter which variable we choose to solve for? No. So you can choose either one. Okay. So that's kind of up to you. So I would have solved for the x. And so to get x by itself, I need to subtract y from both sides. So x equals negative 12 minus y. And again, you could take that and change that to negative y minus 12. It's the same answer. Okay, so I found a value for x, an expression for x that we can plug now into that first equation. So I'm going to take this value and plug in that x. I'll write that over here. 2, and then where x is, I'm putting negative 12 minus y, and then minus 3y equals 6. So that's the equation I'm going to use to find out the value of y. Alright, so once you got the equation with just one variable, now I need to solve for that y. So I'm going to start by distributing my 2. 2 times negative 12 is negative 24. 2 times negative y is a minus 2y. Minus 3y equals 6. And so first step there, all I did was distribute the 2. Okay, what could be my second piece? Combine like terms. So the negative 2y minus 3y in the middle. So I got negative 24 minus 5y equals 6. Thank you, son. Have good attention. Enjoy the dollars. What do you use for your phone like that? I wouldn't call you out here.
I already do.
Okay, so I combine the two y terms, and so the next step would be to add the 24 to both sides so that y is getting close to being by itself. So it's negative 5y equals 30. Negative 5y equals 30. And then the next step is to divide both sides by the negative 5. So y equals negative 6. Good. So we found the value for y. It's negative 6. So now we need to find the value for x. I'm going to plug in the negative 6 back into our x equation. So x equals negative 12 minus a negative 6. And I have to have both minuses because the 6 is negative and the y was also a minus. And so negative 12 minus a negative 6 is also a negative 6. So my solution is negative 6, negative 6. Okay, so that's two problems that we did using solving equations, systems of equations using substitution. Okay, so what questions do you have at this point? None? Good. All right, so let's shift. Remember, I'm not going through this right now to completely make sure you ace this. I just want to give you an idea of what's going to be on the pretest on Friday. If we struggle with the pretest, it's over this stuff that we'll spend a lot more time over the next week and a half to 2 weeks work with this again. Okay? I just want to kind of see where you stand, but I didn't want to give it to you without giving you at least a little heads up on it. So, all right, so the next piece is we're going to solve systems of equations using a process called elimination. And so somebody give me a definition that you think elimination could mean. Okay, it's not a real difficult one. I think I heard one answer. Elimination means to get rid of something or to take it away. Okay, we do want to make sure that that we're getting rid of variables so we can solve for the other. Okay. So similar to the last one, we solve for one variable so we can make the other equation just have one variable in it. Okay, we get the y equal to x, so we replace y with an x value. In this one, we want to get rid of one of the variables so that we can just solve for the other. So what I want to do for elimination is I need a coefficient on one of the variables to be opposites of each other. So if one is a positive x, the other one is a negative x. If one is 7y, the other one is negative 7y. So I want it to be, one of the coefficients needs to be opposites of each other. Because what we're going to do is we're going to add the two equations together and get a new equation to work with, but I want to eliminate one of the variables. So in this problem, the x term already has opposites, those coefficients. You have a 4x and you have a negative 4x. So what happens if I add 4x and negative 4x? I get 0. I eliminate the x. And that's the goal when you're trying to solve using elimination. Okay? So, since this coefficient here is already an opposite, then all I'm going to do is add my two equations together. Okay? So, 4x plus a negative 4x eliminates the x. 2y plus 3y is 5y. And 9 plus 16 is 25. Now, to solve for y, I need to divide both sides by that 5. That gives me y equals 5. Well, I solved for y. Now I got to go back and solve for x. Do what? Now, but I still need an x value because I was using a process. Okay, that's not. I didn't get rid of the x completely. I just did to get rid of it to solve for the y. So now I'm going to go back to one of my original 2 equations to solve for x. So I'll just use this first one. So 4x plus 2 times 5 equals 9. So I replace the y in that first equation with the 5 that we've already found. Okay, so if I solve that, that's 4x plus 10 equals 9. Okay, so what's the next step? Okay, subtract 10 from the 10 and from the 9. So that gives me 4x equals -1. And then I divide both sides by 4. So x equals -1/4. So my solution is -1/4 5. Now I'm guessing if you were doing this, the majority of you would have divided -1 by 4, and you would have gotten the solution of -0.255. And that is also the same thing. So it's correct answer. Okay. All right. Alright, so here's the next problem, and probably the last one we will do today. 2x plus 7y equals 4, and 3x plus 5y equals -5. And we want to solve this using elimination. Okay? But there's a problem I have here. What did we have to have to use elimination? Had to have opposite coefficients on one of the variables, and we don't have that on either one of them. Okay? The good thing about math is that you can always multiply an entire equation by a constant, which is just a number, and it's still equal. It's still true. It's still equal. And so what we do is we try to figure out a number we can multiply by to make one of the coefficients opposites. So if I just look at the x, I have a 2x and a 3x. One of those needs to be a negative, and I need to get the number in the front the same. So what I can do is I can multiply that second equation by -2, which the 2 comes from there, multiply the first equation by 3. When I do that, 3 times 2 is 6, -2 times 3 is -6. So I would have opposite coefficients on the x term. Okay. The issue with this, though, is that you have to do a little bit more work because you have to distribute that 3 and that -2. So you're writing 2 new equations. Okay, that are congruent, they're equal, but you got to rewrite it. So 3 times 2x is 6x. 3 times 7y is 21y. And 3 times 4 is 12. In that second equation, negative 2 times 3x is negative 6x. Negative 2 times negative 5 is minus 10y. And negative 2 times negative 5 is a positive 10. Okay. So at this point now, I have 2 equations with opposite coefficients on the x. So at this point, I can add the equations together. Because when I do that, my 6x's cancel out. So 21y plus a negative 10y is 11y, and 12 plus 10 is 22. And what's everybody okay with that? If you don't quite get it yet? Okay. Then to solve for y, I divide both sides by 11, so y equals 2. Next step. Now that I have y, what else do I need? I need x. So I'm going to take my 2 and I'm going to plug it back into one of these equations for y. So we'll just start with that first equation. 2x plus 7 times 2 equals 4. So in that first equation, the original one, I just replace the y with a times 2. And at this point, you shouldn't have to wait on me to finish this problem. Go ahead and try. Multiply the 7 and the 2. Then subtract that answer from the other side. And then divide everything back to the end. Alright, so to finish this, that's 2x plus 14 equals 4. Subtract the 14 from both sides, so 2x equals negative 10. And then divide both sides by 2, and x equals negative 5. So your solution is negative 5, positive 2. That's my order there. Okay. So here's where we stand for a couple things. As a couple of y'all are finishing up writing. Tomorrow we will for sure look at systems of linear inequalities. So we'll be graphing inequalities. So you'll be shading on a grid. for the most part, y'all did a really good job today of paying attention. There's a few of y'all that lost some points because you slept or had your phones out. Or not even necessarily slept, but had your heads down or your eyes closed. Just honestly, you weren't paying attention at all. But there wasn't very many of y'all that did that. You did a good job, except for a couple of keeping phones put away. And they know who they are. Most of y'all heard that too. So, sorry. And then during math facts time, you need to make sure you are working on math facts. Tomorrow, you need to come in with a book to read. Okay, it is beer day. I would like to not have to have anybody in my book club with Mr. Davis after school. So have a book to read. Okay. Any questions? All right.